Modern marvels of architecture. Burj Khalifa in Dubai, the Shard in the City of London, the Guggenheim Museum in Bilbao. They all impress with the scale of their physical size and the scale of their ambition. Some seem to defy gravity, while others seem like something lifted from the pages of a science fiction novel.
Why do humans decorate? Why do humans design? Why do humans build?
Good architecture, and the kind of architecture that we're still talking about today from all these thousands of years ago, we marvel at the way they're built and technological innovations and so on. But there's something much more than that attracts us to them, and it seems to be a rivalry perhaps with nature.
First of all, it probably touches on an innate human desire and longing for something beyond this natural world, something metaphysical.
If we speak about footprints of civilization, and especially in architecture, in design, and focused on buildings mainly, or other structures made by man, we can compare, of course, the old structures, ancient structures, to the new ones.
The White House, it looks like a palace. It has a monumental facade that makes it look like a temple.
In this episode of Footprints of Civilization, we peel back the layers of time to discover that behind even the most space age of modern buildings, there's an incredible legacy that stretches back centuries.
If we are in ancient times, in Egypt times, we can see that the pyramid was built for someone who was the number one in Egypt. It was a pharaoh. He was like a god.
Their footprint is the idea of certainly power, but also the idea of aspiring to something beyond the physical, beyond the human. The Greeks turned that into something dynamic, something expressive that brought the supernatural, the metaphysical, the divine a little closer to humans. And the Romans were somehow able to combine the two, make the divine, the transcendent, the metaphysical incarnate, that is allowing humans to perhaps feel themselves divine.
The achievement of the Romans was to combine three basic elements, that is, the arch as an architectural form, together with concrete and brick. These three elements, combined in various forms, provided the foundation, as it were, for all Roman great building achievements.
Today, we build the high-rise buildings also for kind of spiritual reasons. The spiritual reason may be commercial purpose, money. It's a new religion.
The primary function of architecture at origin is to provide shelter for people from the elements, and that starts happening when people decide to settle in one place, whether it's permanently or if it's just for a season, for hunting or fishing, for example, or to graze their flocks or whatever it is. Early man moved around a lot, was nomadic. And there must have been all sorts of temporary buildings. Igloos, for example, are still made today. And those are evanescent structures, of course, because they will melt eventually.
The ancient buildings were made from natural objects, trees bent over to create some sort of shelter. There is something about man's innate makeup that makes him want to improve upon nature. That old idea of nature versus nurture. And so we see, first of all, the architecture imitating what were natural forms, tree trunks, bushes of flowers, etc.
Aside from creating buildings that were purely functional, Bronze Age societies also had an interest in design. Look at some of the architecture they left behind. It's beautiful.
We humans very much like to feel that we are in control of everything, which is why humans naturally tend to prefer symmetry as opposed to asymmetry in architecture and design.
The ancients imitated shapes and forms found in nature, a footprint of civilization visible in modern design.
If we look at any modern buildings, a lot of the forms inside buildings, on the exterior of buildings, still imitate tree forms, vegetative forms, and even if we have a stark building of glass and steel, within that building we have waterfalls added, we have plant forms, trees adding greenery to the shape of the interior foyers, etc. If you think, for example, the Gherkin in London, it looks very much like a piña. It looks very much like a pine cone. I mean, that's one obvious example. The sheets of glass arranged on the exterior look very much like a classical pine cone.
We start our journey with the majestic pyramids of ancient Egypt. These structures are still with us today and still inspire the same awe as they did when they were built. The pyramids were built horizontally by stacking bricks one atop the other. It would be a journey of many centuries before the vertical construction of Burj Khalifa, today the world's tallest building.
It has always been the same while we build horizontally and vertically. Vertically, we build something that is important. We build in centers. We build something where people go together for some reason, spiritual reason, business reason. Horizontally, we build for living, for infrastructure.
You may be confined to build vertically for practical purposes. That is, you need the space where you are confined by the space. The other idea, expanding on a practical level, could also be due to space. That is, you are not confined by space, and therefore you are naturally going to expand.
Standing 828 meters tall, Burj Khalifa has dominated the Dubai skyline since 2009.
In fact, it is a competition around the world for the past 20 or so years regarding the skyscraper. That it's primarily humanity's desire for the expression, the visible demonstration of power. We then project that back onto, let's say, the ancient Egyptian pyramids, that was part of it as well.
The pyramids of ancient Egypt were built as massive mausoleums for the pharaohs and queens, and were intended to last for all eternity.
They had a picture of a very happy afterlife and living an Egyptian form of paradise in a sort of a field of reeds and a place of plenty. But the Egyptians didn't just build permanent structures for death. They also built temples, and these are gargantuan affairs as well. And the two have to be thought of together, because the temples are houses for gods, and the gods are eternal, and tombs are houses for the afterlife, and the afterlife lasts an eternity.
The most famous pyramid of all, the so-called Great Pyramid of Giza, was built around 2500 BC and is largely still intact. Also called the Khufu Pyramid, after the pharaoh Khufu, it is the largest of the 3 mausoleums at the Giza Pyramid Complex. Now, when we say large, it's about the same height as a 50-story building. predating high-rise buildings by thousands of years. It's amazing to think that for over 3,500 years, it was the tallest man-made structure on Earth until Lincoln Cathedral in medieval Britain. The ancient Egyptians were truly reaching for the sky.
Rather than thinking of them representing man's ambition to touch the sky, it could also be the endeavour of man to bring the celestial world down onto the terrestrial. And if we think about the shape of the pyramidical buildings, in many ways they look like the rays of the sun scattering upon the earth. So it could be that it's not man just merely aspiring to the heavens, but the heavens being brought down by man onto earth, the celestial meeting the terrestrial.
The outer casing of the Great Pyramid was originally composed of 2 million square feet of white limestone. Just imagine how the Great Pyramid must have looked 4,500 years ago, gleaming white in the sun.
Before, in ancient times, people were impressed by spirituality of the building. Today, the people admire engineering practice, engineering inventions, and they feel impressed of new structures, not because these structures present some spiritual meaning to them, but for engineering techniques. How can engineers build today such high structures? Will it fall down or not?
Ambitious modern buildings require thousands of laborers, craftsmen, engineers, and specialists of all kinds. Tombs dating back 4,000 years contain skeletons of pyramid-building workers, along with jars of beer and bread for their afterlife. They were valued workers. Common slaves would not have been buried with such ceremony or so near the pyramids.
Within those structures, there's going to be a hierarchy of slaves in which the slaves themselves are going to be increasingly technically skilled. And we'll find that after the stones have been blocked, for example, then we're going to have more refined and skilled workers carving, putting the decorations on, painting, moving the shape, moving the blocks of stones into position. All of this is going to require a whole hierarchy of slave labour, from absolute brawn to technical skills, even below the architect.
Of course, it wasn't an easy life by today's standards, more like hard labor. To raise the Great Pyramid, these laborers had to move into position 6.5 million tons of stone with nothing but wood and rope. So much for the workers. But did the Egyptians value their master builders? The planning involved in pyramid building required constructing not only the pyramids themselves, but also boat pits, worker housing, temples, and cemeteries.
The appreciated architects or famous architects were always connected to the court, to the pharaoh, to the aristocracy, to the king. And these people were the only people able or capable to combine the art, design and technique.
The first architect for whom we have a name is Imhotep. And Imhotep built not the Great Pyramid at Giza, but built the first masonry pyramid, or first pyramid form, the step pyramid of Zoser at Saqqara in the 2600s BC.
The Great Pyramid was built by Hemenu, who was responsible for all royal commissions. Perhaps Hemenu was one of the first superstar architects, or starchitects, a line of master builders that stretches to the present-day greats like Frank Gehry, Zaha Hadid, and Renzo Piano.
These people were looked as a futurist. They were able to do something that other people couldn't do. The artists couldn't build structures. The engineers couldn't pay attention to the art. But architects is someone who combines the two.
These people aren't just designers, they're not just good designers, they're not just inspired designers, but they're really stars, and there's only a few of them.
But what is this area like today? These are the remains of Amarna, an Egyptian city built more than 1,000 years after the pyramids at Giza. The city's remains tell us something about early urban planning. The city was located on the east bank of the Nile, and we can see from its ruins that it was laid out north to south along a royal route. The royal residences are to the north, and in the center were apparently the administrative and religious areas. The south of the city and its outskirts were made up of residential suburbs. The planned city of Amarna was built in less than 20 years. It was a forerunner of today's towns like Milton Keynes, Brasilia, Canberra, and New Belgrade.
Many cities were built naturally from small cores of towns with small church or in ancient times similar sacrifice building, and the buildings surrounded the church and the city grew. And it's natural and logical procedure. But if you push very ambitious projects, you have money to do this, but something is missing behind the good reason, a natural reason, or evolution, or good purpose. These ambitious projects end by total disappointment or abandon.
The sheer ambition of the pharaohs, though occasionally misplaced, left for us these great works. Some footprints of civilization get left in the dust by vital new cultures rising up to challenge their primacy. Emerging around 800 BC, ancient Greece was the source of ideas about democracy, justice, art, and beauty, which are still influential today. But even they look to the past for inspiration.
Minoan art and architecture, obviously the precursor for Greek art and architecture. In some cases, very similar. Some scholars have suggested that really there isn't much of a difference between Minoan art and Greek art, or at least early Greek art.
The Minoans were the forerunners of modern Greeks, the ancient Greeks of the ancient Greeks. This is the Palace of Knossos, the remains of a Minoan city only found and restored in the 20th century. Knossos hints of a sophisticated civilization. Astonishingly, they built aqueducts and, yes, had even figured out indoor plumbing. These are things we take for granted, but were unknown to Bronze Age man until the Minoans.
They introduced, for example, in Palace in Knossos and Crete, system of sewage, and the fresh water was brought into the houses.
The Minoan civilization had indoor plumbing, including flush toilets, and that was continued throughout the ancient world, even up through ancient Rome. With the collapse of the Roman Empire, such capacity for what we would call plumbing, water management, was lost, and it would not resurface again until the 16th century, the late 1500s.
Our early European ancestors seem to have figured out the good life. Yet their advances didn't save the Minoans from a volcanic eruption on the Santorini Islands and the subsequent tsunami that decimated their largely coastal populations. So much was lost with the fall of the Minoans. But the Greeks were already picking up where the Minoans left off.
If we think about archaic to classical Greece, there are three types of monumental building, basically. We have the great palaces of the kings, Mycenae. We have temple structures, and we have tombs, monumental tombs. The tomb of Mausolus at Halicarnassus being the most famous and obvious example. These three buildings are all monuments to power of some sort, the power of the gods on earth in the shape of the king, and the power of the king to continue in the afterlife. So we have a sort of continuum through those three types of building.
I think that the main Greek innovation in architecture, design or building is open space. And this open space was allowed only by another invention, it's column. Huge and high-rise column that can bear new type of roof. They allowed to builders to construct bigger spans, bigger halls, where people can meet, can use these spaces in different way than before.
No matter where you are in the world, chances are you've come across examples of architecture inspired by ancient Greece. The Oslo Trading Building, Norway, the Bolshoi Theatre in Moscow, Buckingham Palace, and even the Auckland War Museum in New Zealand. These are all examples of neoclassical buildings. Neoclassical architecture was also known as Greek Revival. It was particularly popular in the 18th and 19th centuries, but there are plenty of modern homes built in Greek Revival style. The Greek architectural influence continued through history.
Especially when Washington, D.C. was being planned, in fact, there was a conscious selection of architectural models, especially from what was the world's oldest democracy, to suit the capital of what was one of the world's newest democracies. So there's conscious imitation there.
These buildings were intended to make a statement about power, whether spiritual or political in nature. They are majestic buildings even at first glance.
If you want to impress people, if you want to make a statement or something, you must go higher. You go to the upper levels. If you enter the bank today, if the lobby of the bank is small, you don't respect the bank. The lobby must be a high-rise ceiling. If you go into the government building, there must be high columns, wide lobby. You respect such an environment. And in ancient times it was the same, so we can see the footprints from ancient times till today.
People obviously thought of things in terms of prestige, and a building project like the Parthenon in Athens is a prestige building. But before it's even that, and before it even represents the city, and before it even becomes a symbol of Greece, as we are now told it was the house for the goddess, Athena, who was the patron goddess of Athens, from whom the city takes its name, and therefore that democracy as well.
The columns are so high that people felt very small. They respected the building. If you go to other times, you can see many copies of Pantheon, but these buildings are modern buildings.
The White House was built 230 years ago as a symbol of a newly formed nation that valued some of the long-lost classical Greek ideals.
The mere fact that it's built on Capitol Hill is in itself proof that we have a continuum from ancient Rome through to the new states of America. There's also a nice story that there was a debate right at the beginning of the foundation of the United States about what would be the language, whether they would continue with English or ancient Greek. And in actual fact, there was a very narrow vote, if I remember correctly, that English only won out by a couple of votes, and it could have been that the new states were actually going to be speaking the new democratic language of ancient Greece.
Back to specific architectural features. The Greeks didn't exactly invent the column, but they certainly perfected it. And with the discovery of marble as a building material, which they embraced, Greek architecture took a giant leap forward.
You could think of building a building that might last an eternity. Brick crumbles, wood rots, but marble just seems to stay there. And the densest and the hardest marbles that take the greatest polish seem to endure all the more.
We are trying always to use the material that is around us. Sandstone, for example, in pyramids. Today we use a steel.
Marble allowed the Greeks to design and build in ways thought previously impossible.
Marble was building material at the times, but engineers or architects of that time, they invented that it can withstand much higher load that they could imagine. So they started to build high columns, and the marble has so big loading capacity that they tried to dare a little bit more. They built thinner columns.
What the column did, particularly for ancient Greek architecture, there were already monumental buildings elsewhere, and there were monumental buildings in archaic Greek. But the column allowed buildings to be airy. It allowed colonnades, for example, places where people could walk, take shade, and escape the dreadful heat of the midday sun. So the columns were only useful for support of the building, but they also supplied an aesthetic in that they allowed an airiness to a building that had previously not existed.
Closer to home, isn't it astounding to think that the Greeks even pioneered an early form of central heating? They spread the heat from a fire through pipes hidden under the floors, which then heated their houses. Naturally, the fire would require constant maintenance. The classical world had a long run. To paraphrase Edgar Allan Poe, after the glory that was Greece, there was the grandeur that was Rome.
Definitely a big footprint that the Romans left.
The Romans invented new structures, new building typologies.
The Romans, as rulers of the known world, had an ambiguous relationship with nature. They thought nature was there to be tamed. The Romans always take something that other civilizations have done and elaborate upon it. They are not great innovators themselves, but they're great elaborators. They take an idea and run with it.
The conventional wisdom has it that what the Greeks first invented, the Romans improved upon.
Once the Romans expand throughout the Italian peninsula, and certainly by the 3rd and 2nd centuries BC, they are now able to use the same materials that the ancient Greeks had already been using for centuries before, most especially marble. So they not only copied what they saw the ancient Greeks doing, but they wound up copying the methods and techniques that they used as well.
A modern glass skyscraper, gleaming in the sun, owes more of a debt to ancient Rome than you might think.
Glass as building material of today, where we can see it on facade, we can see it in windows, in doors, everywhere, has the same structure or same function like it has 2,000 years ago.
Glass is certainly used by the Romans because there are glass window panes that have been found at Herculaneum. Now, it's a very kind of thick glass. It's slightly opaque. You can see through it, but it's a distorting image you see. Because it wasn't important for them to actually look through a window. What was important was that the window illuminated the interior.
Glass windows in Roman times were first used mainly in the building of public baths, a neat solution to stopping a draft.
Modern contemporary culture takes for granted the use of glass, particularly with architecture. It provides you visibility and provides you a degree of security. That's true in more and more in these very beautiful skyscrapers. But now, innovation in architecture using the glass from the outside reflects what is also around it.
By the 1st century AD, homes were being fitted with thick glass windows. In addition, the Romans were also the first to mix and create concrete. The Stadium of Domitian and the Colosseum are two great examples of their use of concrete.
In any event, we're talking about the very late 1st century, so the 80s in the 1st century. And that was probably, those two structures, certainly in the city of Rome, could mark the beginning of what would then become a centuries-long construction campaign relying more and more on concrete structurally and less on stone.
Purely technically speaking, concrete is the assembly of lime, stone, and water. The lime comes through the chemical reaction with water and binds the stones together. In such a substance that has some time to mature, the capacity or loading capacity of such a material is very high.
Also, Roman concrete was made with pozzolana, which was the main ingredient in the mortar, which is a sort of volcanic sand, which came from pozzuoli, or puteoli in Latin, in southern Italy. And that was incredibly strong. It had hydraulic properties, so it would set underwater, for example. It wouldn't disperse in water, it would set. Now, you can imagine that's very important if you're trying to build a bridge or if you're building a harbour or something like that. Many practical applications to it. And then when it's set, it really went rock hard.
They called their concrete pozzolana. It was both versatile and durable. Even better, they could produce an unlimited supply. That was certainly not the case for the Greeks and their marble. The Romans still had an appreciation for the beauty of marble, but they used it as a final layer or veneer. Within, there was usually concrete doing the heavy lifting. The Forum in Rome, the Colosseum, and the Pantheon are all visited daily by thousands of tourists. All those structures owe their long lives to concrete.
Think of the Pantheon, a huge, huge building, and that dome doesn't have a single reinforcing bar in it, and it's still there. And in that particular case, the Romans were even more clever, because as you go up through the building, the aggregate, so what you throw into the mortar to give it body and make the whole thing cohere, was changed. It was graded, so at the bottom it had pieces of marble, so very dense, hard stone. And by the time you got to the top of the dome, so where it's curving over, you would have just tough tufa. So that made the actual weight of the structure itself lighten as it rose to the top.
Modern-day sporting stadiums like the Beijing National Stadium in China greatly impress with their size and sheer crowd capacity. It too owes a debt to the ancient Roman amphitheaters, the first massive sporting and entertainment stadiums. The footprints of civilization can also be found on the playing fields.
We can see, of course, similarities. Colosseum was a place where people met for even performance or fighting or whatever. Today we have exactly similar places. They don't look like Colosseum, but still they gather many people, and these structures are fantastic. These are big stadiums or big event halls.
The Colosseum is predicated upon the arch. Without the discovery of the arch and the combination of the arch and concrete and brick, it could have been constructed certainly to the height in which it stands today.
There's entrances to the entire perimeter of the Colosseum, and each of those is numbered as well. So this meant it was an extremely efficient way of getting 100,000 people into the building without them being trampled and being able to do it in a short period of time. So the staircase system in the Colosseum and the ramp system to feed people into it, and all the various different levels of the building as well, that bears easy comparison with a modern arena.
What a sight that must have been. As with today's big-budget entertainment spectaculars, from superhero movies to rock concerts, the Romans threw everything they had at these extravaganzas. Not even the biggest title fight in Las Vegas can compare with the Roman Games. Unlike today's entertainment, the stakes were high for the participants. Not just box office returns, but life or death. And if some people complain about today's entertainment being too violent, they should just reflect on the Romans and their bloodthirsty games. Sometimes the footprints of civilization don't seem so civilized.
The technique that we admire at Colosseum, that 1 week there was a fighting match, then they flooded with water, there was another performance, etc. It changed quite quickly, and they could do it within 1 day.
It used to be said that the flooding of the Colosseum was a myth invented by the poets, Martial in particular, who says that in the inaugural games, the land magically appeared from sea in the morning. Recent archaeological work has shown that the poet was probably correct. It seems that the drainage system that was used for draining Nero's lake was later reused for draining the Colosseum. Now that doesn't really explain how the Colosseum itself was flooded, but it has been suggested that around the arena area there are about 40 channels, drains, that would fill the Colosseum with rainwater. So we only have to imagine tanks outside the Colosseum which could be released to flood the Colosseum, and then the old drainage system opened to let the water out again.
What are we doing today in event halls is the same. Monday we have an ice hockey match, Wednesday we have a concert of pop star, and Friday we have motorcycle races.
But the Romans left us with more than just a passion for violent spectacle.
The invention of the ark was also revolutionary as the column in Greek times, because with the ark or statics of the ark you can do bigger spans than with the columns.
Arches are made up of blocks that are called voussoirs. They're wedge-shaped blocks that fit together, and they make an arc. And this is what gives the arch its stability, is this compression. The keystone at the top is the last of these wedge-shaped stones that's inserted. And once that's inserted, the arch is completely stable.
The Egyptians and Greeks had used arches mostly underground, in vaults and sewers. The Romans took the arch to new heights. This is the Mike O'Callaghan Pat Tillman Memorial Bridge. It spans the Colorado River between Nevada and Arizona, part of the Hoover Dam Bypass Project. What it owes to ancient Roman ingenuity is not difficult to see. It's the widest concrete arch bridge in the Western Hemisphere, and it's the arch design of this bridge which enabled builders and planners to overcome hundreds of meters of steep cliffs.
The bridges that were built 2,000 years ago and we are still using today is not really because of invention of concrete or other materials. It's because the architects of that time, they had no such a precise means to calculate the structures. They just put a lot of materials according to their experience to withstand the loads. So the bridges of Roman times were over-calculated, and that's why we can use them still today.
The Pont du Gard aqueduct in the south of France is another good example. Arches were an essential component of Roman aqueducts and bridges. They were not built from concrete, but from limestone. The spectacular Pont du Gard was still in use until just a few decades ago.
Other civilizations had brought water distances to supply cities, but the Romans elaborate upon this and bring water from distances that previously had not been imagined.
The largest aqueduct feeding the city of Rome was completed in the middle of the 1st century under Emperor Nero. The population of the city of Rome was about 250,000 inhabitants. Only 70 years later, by the time Emperor Hadrian, the population of the city of Rome explodes to roughly 3 million inhabitants. In 70 years, one reason: the aqueducts. Suddenly, every Roman, the poorest of the poor, the wealthiest of the wealthy, had 24/7 access to clean, fresh, potable, sanitary, drinking, free water.
Water was fed to various urban outlets. In houses, it would only be the houses of the very rich, obviously, but also to public fountains. And some of these fountains were built on a colossal scale. But if you want to get some idea of the kind of excitement of that, the arrival of water from another world, you know, from the mountain, you can't do better than go and see the Fontane di Trevi, which is very much in the spirit of the Roman aqueduct, and is fed by a Roman aqueduct.
That original fountain was supplied with water pumped from an aqueduct, which also supplied water to the Roman baths.
The public baths were a great Roman invention. The idea that one should bathe communally in groups, either mixed or segregated, was something that the Romans took to the nth degree. We think of the great baths of Caracalla, for example, which are like huge sports, social complexes as well as bathing complexes.
You could joke that the Romans really put the art into architecture. The footprint of their genius for building can still be seen today.
The arch today is really more of an ornamental feature on buildings, and that's because building technologies have changed.
Whether stacking bricks together in a single building or creating whole blocks of buildings, Roman urban planning may be surprisingly familiar.
Romans' main architectural achievement is in city design and city layout. We think of the grid system of modern cities like New York. That is totally predicated on a Roman military camp. When the Roman military machine moved north, south, east, and west, its encampments, be they small or large, formed the basis eventually for most of the modern towns across Europe. Cologne, Vienna, Paris, London.
Footprints of civilization in architecture can be seen everywhere.
The Burj Khalifa in Dubai, the Bird's Nest Stadium in Beijing, the Mike O'Callahan Pat Tillman Memorial Bridge in the U.S. Modern-day architecture dazzles with its height, its scale, and the shapes and forms never seen before in building.
Architecture is the environment you live and prosper in.
It makes you wonder how these modern-day masterpieces will be viewed by people hundreds, even thousands of years in the future. Or indeed, if they will stand the test of time, the way ancient architecture has. These buildings are testament to the ingenuity and willpower of the ancient world.
There's always been that idea that man could improve upon the natural world.
The Romans, unlike any other ancient civilization really, was able to dominate the landscape.
The ancients created the building block for the world around us, one we simply take for granted. So, wherever you look, so long as you know how to look, you'll see all around you the footprints of civilization. The scientific discoveries and technological breakthroughs of the ancient world have shaped our lives in so many ways.
Knowledge is always helping people to understand and to take decisions, also to develop a technology based on science, which can improve the daily life.
In this episode, we'll trace those footprints from prehistory to the present day, from the invention of the wheel to new land speed records, from battlefield surgery on Roman gladiators to the technological strides made in a world war.
One of the most obvious footprints of the ancient world is the use of the wheel.
The passage from the hunters and gatherers to the farmers can be considered to be the most important revolution of prehistorical times.
First thing that is coming to my mind is the calendar. Of course, it's on every mobile phone, and we use it, and now it's sort of the whole world is using one calendar because of now the planet is so interconnected.
Since the very dawn of mankind, even before recorded history, science and technological progress helped mold the world around us. Ancient Mesopotamia. This part of the world has often been referred to as the cradle of civilization.
Is that part of the world where so many different interesting elements and techniques and innovations were actually introduced. Speaking of Mesopotamia, of course, the single most important innovation was urban civilization. So the city was basically born there.
And it was here that one of the most important technological developments since fire was thought to have originated. The wheel. It's believed the wheel was invented and developed in Mesopotamia around 3500 BC and has been with us ever since in many forms. The first wheels were potter's wheels, carved out of wood. Later, some bright sparks figured out how to use them for chariots, with 4 wheels and 2 axles.
From the historical point of view, the wheel develops between 3000 and 2000 before Common Era, in different locations.
So you have different cultures perhaps that aren't using this, what then must have been incredibly new technology. They see it, it's very simple in its design, and so it pretty much spreads rather rapidly throughout the ancient world. Famously, the ancient Egyptians, their use of the chariot in battle, having archers moving at very rapid speeds in these chariots mounted, again, on wheels.
Buckle up and hold on to your hats. This is the Hennessy Venom GT. Even its name sounds powerful. It holds the current land speed record, accelerating from 0 to nearly 300 kilometers per hour in under 15 seconds. It can cruise along at 435 kilometers per hour. The Venom GT has other high-performance cars like the Bugatti Chiron nipping at its wheels. Of course, cars like these are powered by an internal combustion engine. But that engine would go nowhere fast were it not for that one particular early invention. This is the atomic clock. It's capable of measuring time within a quadrillionth of a second, powered by strontium atoms. Experts are confident this timekeeper will neither lose nor gain a second for the lifetime of the universe.
Time is really a footprint of civilization. Time was basically discovered or created as a concept by the Babylonians, by the Sumerians.
Of course, what ancient civilization had was looking at the sky, looking at what was happening in nature around them, and they could see that there was a season cycle, for example, that the sun was going in a latitude which were not the equator, up and down during the year at different elevations with respect to the horizon, this kind of observations. And the key word out of this was periodicity.
The Babylonians were perhaps the first people to accurately measure time. They divided the year into 12 months with 30 days in each, divided hours into 60 minutes, and then minutes into 60 seconds.
Both the Mesopotamian civilizations and also the Egyptians introduced the sundial, or the obelisk in the case of the Egyptians, in order to measure the passing of time, the movement of light, which would indicate the shift from one period of time to the following.
Okay, the Babylonians' degree of accuracy was not quite a quadrillionth of a second, but given their Bronze Age technology, it was still pretty remarkable. It's a system that has served us well for centuries.
Then from those Mesopotamian civilizations, these concepts passed on to the Greeks, and then from the Greeks to the Romans, and so on.
In the ancient world, everyone knew that there were certain months, usually at least 4 months of the year, when you did not sail in the Mediterranean. You did not attempt to navigate the waters because they're very rough during the winter, and you therefore risk not only loss of life to yourself and your crew, but perhaps even more importantly, depending on your perspective, the product that you're trying to gain capital upon.
Practically all later civilizations learned from the Babylonians to look to the skies for a deeper understanding of the world around them.
They kept on looking at data and finding periodicities. And then what happens is on the basis of this data, then we have a model. For example, then we now know that the moon is going around the Earth, and then we can interpret this cycle in terms of the movement of the moon.
The Babylonians were also the first mathematicians of note. Babylonian mathematics included a rudimentary understanding of fractions, algebra, quadratic and cubic equations, and even trigonometry. This is the Plimpton 322. It's a 3,700-year-old tablet which is stored at Columbia University. It suggests that the Babylonians were studying trigonometry, the lengths and angles of triangles, well before the ancient Greeks.
It is probably the earliest trigonometric table. So this actually would highlight of the role of the Sumerians from the point of view of developing an approach, an interest towards higher level of mathematics.
According to some math historians, the Babylonians may have even calculated the Pythagorean theorem 1,000 years before Pythagoras. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Who can forget that from high school? It's a formula that is still in use every day.
Most people, when they think of geometry, they cannot but think of the Greeks, Pythagoras, Euclid, etc. The interest on the part of the ancients, and specifically the ancient Greeks, begins with very practical intentions, reasons, purposes. If you want to design something which an engineer can actually build and make stable, you need geometry.
Sadly, we are no longer able to admire the Hanging Gardens of Babylon. They were one of the 7 wonders of the ancient world, a marvel of Babylonian building. But what is left of Babylon looks geometrically correct. We can also see from the Babylonian pyramids, so-called ziggurats, that they understood that the triangle was the strongest form in geometry.
It was also pretty much used for engineering purposes or reasons. If you need to build structures such as pyramids or the ziggurat in Mesopotamia, for example, so temples or other huge buildings, you probably need to calculate precisely how these structures should be constructed.
This computer graphic, a theoretical reconstruction of the Tower of Babylon, clearly illustrates the importance of geometry in building. The beginnings of geometry left an unmistakable footprint of civilization. Standing atop the ziggurats and looking up at the night sky was the beginning of another scientific discipline. Nearly 5,000 years ago, Babylonian stargazers became the first astronomers.
Of course, astronomers did use mathematics, and they still do it. Especially, I would say, geometry and trigonometry was much needed. Why? Because astronomy has to deal with movements in the sky. So, mathematics and physics are always somehow catching up each other. Sometimes mathematics is going farther than what physics is able to catch it up, and sometimes the opposite. The physicists discover something that needs mathematical modeling to be fully understood and modeled.
The Hubble Space Telescope has greatly expanded our knowledge of the universe. Launched in orbit around the Earth in 1990, it's the most powerful telescope ever built. It's about the size of a school bus, but unlike any school bus, it can span the distance between London and Los Angeles in under 20 minutes. It's almost as much a time machine as it is a telescope. Why? Because a distant galaxy appears through its lens as it did when the light left it, which might be millions of years ago. And it's all a long way from the ancient Babylonians, standing on tiptoes atop their ziggurats. They had a similar purpose, to figure out our place in the universe.
They did not really have the instruments that we can rely on today, of course, but they did have some instruments, some sort of technology that they could employ for their observations. The armillary sphere, for example. All those instruments were employed not really to inquiry into the nature of the celestial bodies, but rather to measure their movement.
Now we have astronomy, but astronomy is fascinating, and especially technologies, is is able to fascinate people as much as looking at the stars in former times. Because what do we have? We discovered, we have now the space exploration. We have orbiting observatories around the Earth. They sent us incredible images of the universe, of what's happening in the universe, of the Milky Way, what are the surfaces of the planets.
By around 2000 BC, or 4,000 years ago, the Babylonians were recording lunar eclipses. By 700 BC, they could predict lunar eclipses based on their record keeping.
Prediction is another characteristic of science, how you can predict, and for example, predicting that winter will come again. This on the basis of observations. Predicting an eclipse. This was a big issue in former times. At that time, science and religious belief were a little mixed up, so people were afraid. If the moon was suddenly becoming dark or the sun was disappearing, there was a lot of fear. And so the governments had to know it before.
In order for civilization to develop, a revolution had to take place that should never be taken for granted. Mankind shifted from being hunter-gatherers to farmers.
The passage from the hunters and gatherers to the farmers happened roughly 10,000 years ago, at the time of the Stone Age, occurring between the Paleolithic and the Neolithic. So this is the period of time in which you have this shift from those who relied on hunting and gathering what could find, basically, to those who decided to settle within a specific portion of land or territory, grow their crops or domesticate their cattle or other animals.
As sure as the sun rose in the morning and set in the evening, the ancient Egyptians needed food and water. Then, as now, most of Egypt was a desert. However, every year the Nile would flood, spilling over with water that flowed down from the mountains to the south. But when the water receded, it left behind rich soil in which the ancient Egyptians grew their crops. To irrigate their crops, the Egyptians created a canal system. They built gates to these canals so they could control the flow of water, and they built reservoirs to store water in case of drought. Whatever the drawbacks of early agriculture, the majority of ancient Egyptians could now feed themselves. Once a society is able to do that, it can flourish and develop in all sorts of unforeseen ways.
Of course, the society of farmers is much more specialized than the society of the hunters and gatherers. So there is a specialization of the different roles that they have within this society. Also, settlement is one of the advantages of this. While you settle, you can live a kind of stable life. You can have control of a specific portion of territory.
The ancient Egyptians were also obsessed with the night sky. They could identify 5 of the planets in our solar system. They also observed that the rising of Sirius, the dog star with the sun, would precede the annual flooding of the River Nile. Some Egyptologists even believe the Sphinx, the Giza Pyramid Complex, and the River Nile were a mirror image of the constellations of Leo, Orion's Belt, and the Milky Way.
There are many reasons for doing this. Religious as an observatory, because then you use the buildings as an observatory for measuring, for example, time and the transit of stars, or just because it's beautiful.
Research suggests the Egyptians were able to align structures to true north within 1/10 of a degree, as is the case with Khufu's pyramid. But how were the Egyptians able to line up the pyramids at Giza with the 3 stars on Orion's belt? We may never know.
It's nice to think that every, I don't know how many years, a given star, for example, Aldebaran, is peering through the hole directly to the grave of a great king. It has a power for the imagination. There's nothing, it's just geometry. But if you want to see the beauty out of it and the power of building up the whole celestial mechanics that is doing this, to govern celestial mechanics so certain things are happening, this is the beauty out of it.
It's arguably another ancient Egyptian footprint of civilization that we still align buildings with the sun, although this is for practical reasons such as heat and light rather than religious belief. But Egyptian contributions to science and technology originate in some mysterious ways. Strange as it may seem, it was the Egyptian process of mummification that led to some early breakthroughs in medical science. Mummification involved the removal of organs and stuffing the dried body with rags, plants, and spices so it would keep its shape. As they went about their grisly trade, these early Egyptian taxidermists learned much about the workings of the human body. The first heart transplants were performed around 50 years ago, a mere blink of an eye in terms of world history. It was quite a journey from removing organs to being able to perform organ transplants. But that journey began in ancient Egypt and with mummification. Thanks to mummification, Egyptians came to understand much about the human body. They practiced basic surgery, could fix broken bones and dislocated joints, and even stitch wounds effectively. Newfound knowledge mixed with deeply held beliefs. The Egyptians believed they were preparing the corpse of the king for eternal life. Medicine was mixed with alchemy and the quest for immortality.
As a technique, it belongs to a vast species, though, of material transformations, which are not medieval in origin or Egyptian, but being practiced throughout the Middle East in the Bronze Age and earlier. And what's happening is attempts to transform materials, to alter their properties, or to make syntheses of things that exist in nature.
If we consider Egypt, they didn't know how to deal with minerals. From this point of view, we can find some kind of connections between the alchemical aim of finding, of transforming into a higher standard and the way in which they actually used these minerals.
For example, pottery. Even the idea of taking clay from the ground, this wet and malleable substance, and then firing it in a kiln begins to give clay the properties of stone because it's harder. Admittedly, it's brittle, but it's harder. When you then have the invention of glazes that are given to pottery, then this is not only like a stone, but it's like a stone that can take a very high polish.
Now, no alchemist ever found a way to prolong life or transform lead into gold, but their experiments led them to some interesting conclusions.
What sustained it in classical antiquity and right into the early modern period was also the Aristotelian world system, where everything was composed basically of 4 elements: earth, air, fire, and water. It was believed that basically anything could be transformed with the right processes from one state to another. But there was this idea of an essentially infinite intercommutability between elements. Of course, all these ideas were lost in modernity with the advent of the periodic table towards the end of the 19th century, and a completely different elemental view of the world.
Perhaps it's because we are the only earthly species aware of our own mortality, but eternal life, or at least a greatly prolonged existence, is something humans still dream of. Some scientists believe that the first human to reach 1,000 years of age has already been born, all thanks to the thousands of years of alchemical, chemical, and medicinal findings. Ancient Egypt was the birthplace of the medical profession. In those days, people would come from faraway lands to be treated by Egyptian physicians. But across the Mediterranean, another civilization was getting ready to take the baton of progress.
When we think of Greek philosophy, we tend to think of these philosophers maybe in their gardens, working and thinking about pretty much theoretical things. But we need to know that philosophy also means science. So also means something concrete.
For example, knowing that the Earth is round and it's not flat. Discovering what is the size of the orbits of the planets, that is the size of the solar system, the size of the sun. The big discoveries from the point of view of physics are changes of perspective, opening minds to a new way of looking at the world and all the consequences.
Broken down into two Greek words, an intimate love of something. Philia, of what? Sophia, wisdom, an overarching, ultimate wisdom.
The Greeks also continued the good work of medical science. One should not forget that many people at that time believed diseases were the gods' way of punishing sinful humans. But those ideas began to change in ancient Greece, mostly due to the work of one man, a man whose name we still remember. It was around 450 BC when a certain Hippocrates of Kos began conducting experiments to prove the symptoms of disease were caused by the body's natural reaction to diet, environmental factors, and so on. Certainly not by vengeful gods. Hippocrates has been called the father of Western medicine. The Hippocratic Oath, which bears his name, was the first known attempt to set an ethical standard among medical practitioners.
The Oath of Hippocrates is the single most important document in the history of medicine, establishing the medical tradition in the West. So establishing medicine as a sort of tradition, as a scientific and ethical tradition in Western culture.
Hippocrates lived to be 90, a very old age for that time, and his words certainly live on. I will use treatment to help the sick according to my ability and judgment, but never with a view to injury and wrongdoing. Neither will I administer a poison to anybody when asked to do so, nor will I suggest such a course.
In the 1960s, this was still something pretty much used in Western universities, for example in the big British universities such as Oxford and Cambridge.
What is sometimes called the golden rule doesn't change, but our understanding of the world does. What is the universe made of? How did it begin? Physicists today are still seeking answers using particle accelerators, such as the Large Hadron Collider, well named because it's the largest machine in the world. A 20-mile-plus ring-shaped tunnel made mainly of superconducting magnets, some 100 meters underground. Scientists hope this particle accelerator will answer the big questions. Yet around 2,400 years ago in ancient Greece, one man working on his own and without even a small hadron collider came up with some remarkable insights. This one had the promising name of Democritus, who declared that all matter was comprised of atoms, and his footprint is hard to overlook. These atoms were, he said, physically but not geometrically indivisible. He also believed that between atoms there lay empty space. Furthermore, atoms are indestructible and perpetually in motion. But there were many such eureka moments in ancient Greece, including another one we all learned about in school, when a philosopher named Archimedes, stepping into his bath, cried, "Eureka! Eureka!" or "I found it! I found it!" In his tub, Archimedes had, in a flash, understood that the volume of water he had displaced getting in the bath must be equal to the volume of the part of his body he had submerged. In essence, the law of hydrostatics.
Archimedes and what he had, and all the studies about the leverage and the way in which you can actually compute the force that is keeping a ship up. I always thought as a kid, how can an iron ship survive, to still be, is why it's not drowning. Now we take it for granted, but it's sort of study also, this one coming out of science. It's an application of science and of scientific thinking.
Archimedes wrote admiringly of Aristarchus, a Greek astronomer who had lived before him.
Aristarchus of Samos is claimed to be the first one of the first to advance the idea that the Earth and the other planets were actually rotating around the Sun. So we know how this idea then was abandoned after a few centuries.
The heliocentric system was controversial, became controversial in the 16th and 17th century of Copernicus and Galileo for several reasons. One was that it wasn't included in the model of the universe that had been handed down since Plato, actually, even slightly earlier, with the Earth at its center, which had been then canonized, it had been sort of enshrined in the Aristotelian view of the universe, which was the common belief of how the universe functioned, with the Earth at its center and the Sun moving around it like the other heavenly bodies. So it was difficult to shake off that tradition.
So much for the universe, but what about coming back down to Earth and finding ourselves? The Global Positioning System, or GPS, is a mainstay for motor vehicles and modern smartphones. And where would the motorist or traveler of today be without these navigation systems? Completely and utterly lost, probably.
It's important to think that each subsequent civilization is standing on the shoulders, as they say, of a previous civilization. So that's certainly true of the ancient Greeks regarding navigation. In terms of going distances beyond the ancient Greek world, so basically the Eastern Mediterranean, venturing into Asia Minor, modern-day Turkey, or even beyond into Persia, perhaps beginning with maybe Alexander the Great, 4th century BC, and his interaction with the famous astronomers / astrologers from Mesopotamia, the ancient Near and Middle East.
You're looking at an early global navigation system. It is, of course, a map. At over 2,200 years old, it's one of the first known maps of the world, or more accurately, the known world, according to the Greeks. It was the work of one Eratosthenes, a cultured man who ran the Library of Alexandria. One of his most impressive feats was to calculate the circumference of the Earth.
Then it turned out something like 40,000 kilometers, which is extremely close to what actually is the measured circumference of the Earth.
So he went pretty close to the truth just by considering the movement of shadows, the movement of light and of the sun around the Earth. So basically by employing the sundial.
He knew that at a certain date of the year that the sun rays were going straight to the bottom of a well. And he knew that in another place at the same time this was not happening. So one of the possibility was that the Earth was not actually flat, it was round. This was explaining this difference. Let's then get this funny idea of that the world is round, is not flat. Can we measure how big it is? And this is the next major step of science, measuring the universe, cosmology.
The natural philosophers of ancient Greece were so far ahead of their time, it's hard to believe. If the Greeks were philosophers, the Romans were eminently practical people.
More than the Greeks, certainly the Romans did this. And once you've mapped a territory, you know where point X is in relation to point Z. The Romans famously are going to build a road so that they have a connection to that point, which then frees them from having to constantly rely on navigating by virtue of the heavens or even by virtue of maps.
Telling the truth, they were not always innovators, but they were really clever in discovering, re-employing, reusing the others' discoveries. So they managed to use the techniques invented or discovered by the Greeks, and they bent these techniques for their practical military and social political purposes.
With a quite justifiable reputation as the fastest highway in the world, the German Autobahn is a motorway designed just for cars. Anything that can't go faster than 80 kilometers per hour is not permitted on the Autobahn, which pretty much rules out bicycles and pedestrians. There's no upper speed limit on much of the motorway, and it is illegal to stop unnecessarily. That includes running out of fuel. Of course, the only fuel on the roads in ancient times was stamina. But with horses and carts the only traffic, why did the Romans build such sturdy roads? Well, Rome did not become an empire without being able to mobilize its armies.
Communication due primarily to Roman roads, the system of Roman roads that the ancient Romans built all throughout their former empire. That was the primary vehicle for allowing other vehicles of travelers, oftentimes runners, couriers, if you will. That's where the famous Pony Express probably began.
In the 3rd century BC, the Via Appia, a famous Roman road, was constructed, connecting the capital with the port town of Brindisi. Now it's a free tourist attraction, although the first nearly 5 kilometers of the Via Appia, or Appian Way, are still traversed every day by cars, buses, and coaches. Not only that, but parts of Britain's A1 motorway are based on the old Roman routes. So when it comes to transport, in a very real sense, all roads do lead to Rome. They well and truly left the footprints of their civilization. And with their aqueducts, drains, and baths, it's clear that Romans understood the importance of sanitation, placing them way ahead of some later civilizations.
So the Romans would inherit from the Greeks this attention to or for the body. Water was very important for the Romans. We know they constructed so many different aqueducts.
Well, the Roman aqueducts, certainly probably one of their stereotypically most famous achievements, science and technology-wise.
They were among the first, the earliest civilization to connect hygienical purposes, hygiene, and social status and social environment and background.
So it came to be understood, bathing wasn't just a luxury, but a necessity.
All of the aqueducts feeding, for example, the city of Rome begin 60 miles outside the city in the central part of the peninsula in the Apennine Mountains, inside the mountains from natural springs of water. And the problem becomes for the Roman engineer is what happens when suddenly my tunnel comes out the side of a mountain cliff and I'm facing a rather large valley in front of me before I get to the next mountain. And so to maintain that certain gradation for the flow of water, the ancient Romans built what we think of as these aqueducts in order to cover these vast expanses of land until we at least get to the next mountain where we go back inside, or ultimately until we get into the city. The Romans themselves discovered and understood that every certain number of feet within the length of an aqueduct, right, your gradation had to drop by a very precise amount. How exactly the ancient Romans were able to figure that out remains still somewhat of a mystery.
The ruins of the baths of Caracalla outside Rome. In their heyday, with high vaulted ceilings, separate hot and cold baths, they must have been magnificent. The aqueduct which served the baths of Caracalla was in use until the 19th century. The Romans also advanced the practice of medicine by publishing treatises that could be read, well, by anyone who could read. Ordinary citizens also had greater access to professional doctors. Medicines were manufactured, including pills using plants and herbs. Next time you take a pill for a headache, heartburn, or anything really, remember the Romans. The Romans also developed specialized instruments for surgery, ranging from forceps to wound retractors.
Specific kinds of surgery techniques and instruments, especially those dealing with fractures and similar, were also due to their activism within the military field. This is also the reason why they managed to develop these specific substances like morphine or what we would call nowadays scopolamine, that could actually quench the pain of the sick. So they could basically translate.
Even their interest in war seemed to have survived until modern times, and with it, giant leaps in technological progress. Consider technological advances made during World War II, the first jet planes, radar and atomic power. The Enigma machine, a German code device that anticipated computer technology. The German V-2 rockets that were the first man-made objects to ever travel into space.
So from the point of view of war, of course, the Romans developed or reused many instruments, especially as far as siege warfare is concerned. So they invented or just employed oldest instruments that were already employed by other civilizations, by the Greeks, for example, the ballista, the catapult, the siege tower. So all those instruments whose function was that of rendering or making the life of Roman soldiers a little easier.
But it also somehow would be the precursor of what we have really in contemporary civilization, another ancient footprint, creating a greater and greater distance between two enemy forces. It almost numbs one to the impact that such bloodshed, devastation, death, maiming has on the human psyche. So much so to this day that now we have drones, and someone sitting thousands of miles away from the target can rather disinterestedly neutralize, as we like to say, that target. What we really mean is kill, destroy.
In war and peacetime, the technological and engineering feats of the Romans just kept coming. But even the glory of this civilization couldn't save it from a fall that meant a giant leap backwards for science and technology. So what happened to all that ancient ingenuity and know-how? For centuries after the fall of Rome, Western Europe was plunged into the Dark Ages. Agriculture returned to the subsistence farming of the Neolithic era. Literacy receded and was even scorned. Medicine was substituted with blind faith and superstition. But in the Middle East, there was a glimmer of hope. In libraries and places of learning, such as the House of Wisdom in Baghdad, the wisdom of the ancient world was preserved.
Footprints of civilizations are interesting and relevant and important because they say something specific. They say what, as humans, we all share, we have in common, and at the same time, they highlight what, as individuals, we develop in a specific way.
With the 14th century came the Renaissance and a great surge of interest in classical teaching in Europe. Somehow, by the skin of our teeth, humanity had scraped by. Tracing the footprints of civilization saved us once, and if we know how to learn from our mistakes, may even help us yet.
There are many famous sayings about history and about its value. One of the several that I like is to remember not only to learn from errors of the past, to improve positive progress for humanity, but to remember also that we're always standing on the shoulders of giants who have come before us. Scientists, philosophers, innovators, those who are immersed and imbued with the process of critical thinking.
In many ways, we have it so easy. We pick out what we want to eat and drink as we cruise the supermarket aisles or surf the net. It's all there, packaged and labeled, even delivered right to the door. Still, it can be tough putting food on the table. Just talk to your ancestors from tens of thousands of years ago. They could tell you a thing or two about hardship. Early humans may not have had much variety in their diet, but they survived, though the odds were against them.
We have many lessons to learn from the ancient world. Imagine, for example, their water management and how they succeed in growing products.
Greatest probably innovation in agriculture took place in the Mediterranean, in fact, and mostly in the eastern part of the Mediterranean, that is Western Asia, when grains were domesticated.
So it's still very important today, yes, of course. I mean, it's becoming increasingly important. Agriculture is still important because we are taking and receiving from agriculture all that we use for our living, basically.
And the beginnings of agriculture mark the beginnings of civilization.
The connection between literature and farming, and the developments in agriculture, are fascinating. We have a whole series of early literature that is based around the shepherd, for example, and the shepherd's produce, the shepherd's day.
To understand the impact of ancient agriculture, we must first travel to a time before history. It would be quite a journey from early hunter-gatherers to the food orgies of ancient Rome. But these footprints of civilization are with us every day. Planet Earth. According to the United Nations, there are around 7.6 billion people on our blue-green planet. That's a lot of hungry mouths to feed. Worldwide production of grain in 2017 to 2018 came to about 12.38 million metric tons. That's a stupendously large bowl of cereal. Modern methods of grain production use advanced agricultural equipment, irrigation, fertilizers, and pesticide. And to think, it all began with someone planting the first seed. Europe around 40,000 years ago. To get here, early Homo sapiens had to traverse a great distance, having come out of Africa. It's estimated that as few as only 10,000 completed the trek. The rest had not survived the perilous journey. Once they got to the new lands, there were new challenges to face. Our ancestors had to compete with other primate species for the territories of Eurasia, like Homo erectus and Neanderthal man. As they were a nomadic species, Homo sapiens kept moving from place to place, hunting and gathering all along the way.
Very often these men of the Paleolithic also scavenged organs or the fat from animals that had been killed by much larger animals. So they had, different ways of acquiring food for acquiring calories from the mammals, basically.
Then, around 10,000 years ago, someone had the idea to try something different. They planted a seed in the ground.
Well, it's all about taming nature, isn't it? It's beginning to think about man's place within the natural world, taming the natural world, taming animals, taming the earth, taming the waters, and making a comfortable living for oneself.
You have these changes and the transformation of societies, the settling down of people in more permanent villages that become sometimes cities. We also know that these first, let's say, revolution happened in the area of Mesopotamia, the Middle East, and Anatolia.
Though we'll never know who came up with this idea, it took off and spread quickly throughout the entire world. The planted seeds of wheat, rice, and corn meant that future Homo sapiens could stop their ceaseless wandering and live off the land.
They had the possibility and at the same time the need to experience what could they make with this regular staple. Not anymore maybe simple boiling, but more complex process, such as bread making, where you have the dough and you have all the process involved.
With the Industrial Revolution, of course, in modern time, since the 19th century and right up to our own time, storage now has become way beyond what the fresh foods that are available. So what we're struggling with in the contemporary diet is this lack of balance. On the one hand, we are overwhelmed with food that has been stored, prepared foods. On the other hand, fresh foods become less and less available and more expensive because agriculture has become industrial, the process of storage has become more sophisticated. A lot of the fresh foods we had before totally disappeared.
So actually there is a kind of evolution towards the past rather than towards the future in terms of what we want to eat. Today we are looking for healthier food, for a food that can sustain in a more natural way. We are basically going towards the employment of techniques, of methodologies that were already employed by our ancestors.
Evidence suggests there were wheat fields in the Fertile Crescent at least 9,000 years ago. Those first farmers essentially lived on a vegetarian diet, whether they liked it or not. Once humans gained some mastery over the land, they went about the domestication of pigs, sheep, goats, and cattle. Today it's called animal husbandry.
Probably around 6,000 BC, 8 to 6,000 BC, what we might call wild sheep were domesticated, and goats. This was a major lift to the daily diet. In addition to sheep and goats, which were domesticated, this led, of course, to the production of milk.
One of the first settlements from the Neolithic age points to the very beginnings of agriculture and civilization as we know it. It's Çatalhöyük in Turkey, and it overlooks the Konya Plain, southeast of the present-day city of Konya. Today, agricultural scientists continue to use selective breeding of animals as they seek to make the animals' muscles leaner or their milk richer. But how far can we take the science of animal breeding? Imagine an ancient ancestor sitting around with a full belly he got thanks to farming. He never could have imagined the footprints of civilization he was leaving behind. Farming made civilization a natural possibility. Essentially, without agriculture, there'd be no culture.
The early literatures talking about the songs of the herdsmen, the songs of the drovers, the songs of the shepherds. We see farming so intimately connected with the development of literature that it is fascinating. Without farming and the tallying of the herds, we don't get an alphabet developing.
Sumeria was an urban population, therefore it follows the pattern of city development, urban development, and therefore a dependency on outside sources of food. So you can well imagine that we have now a trading element in society. People who are bringing the food in from the rural areas, trading, marketing in the urban areas. Well, this demands some kind of record keeping. Who is buying and who is selling, and all this becomes suddenly important. So the cuneiform script was developed to make those recordings.
The Sumerians, who lived in the part of the world now known as Iraq, were one of the first true civilizations in world history. 11,000 years ago, Sumerian farmers began to grow the cereals, barley, and wheat.
The earliest farmers would develop their agricultural enterprises within a specific geographical location. This is Mesopotamia, the land between the two rivers, the Tigris and the Euphrates.
In many parts of the Middle East, yet today, you will see scenarios where these grains are being planted, harvested, as they were 10,000 years ago. It's only with the development of agricultural machinery that has changed it all, and that's in terms of the overall development of agriculture. This is very recent indeed. And so what puts a great deal of stress into the production of agriculture and food is, of course, the growth of population.
While Sumerians were growing their crops, flocks of wild sheep were being herded in the Zagros mountain range. On today's maps, the Zagros mountain range lies predominantly in Iran. Then, about 6,500 years ago, the invention of the plow took farming to a whole new level, despite the invention initially being made out of the wrong material.
The plow was basically made of wood. That's not the best technology for producing a high amount of food products. The modern farmer would recognize still today, the basic technology in grain production and food production, certainly agricultural production, is the plow.
Around this time, wool was first used for textiles and clothing. The footprints of civilization are found woven into the shirt on your back. Today's global fashion industry generates $3 trillion, or 2% of the world's gross domestic product annually. Here's another way to think of it. The fashion industry, including clothing and textiles, currently employs around 60 million people. During the agricultural revolution, that was more than the entire human population of the world. The first agricultural revolution quietly developed over the course of 3,500 years, but its footprints are still with us. Agriculture transformed humankind and made everything else that came after it possible. It's inescapable. A society that has trouble feeding itself isn't going to last long. Agriculture's upside was clear, but living off the land and living so close to animals was not without its side effects. Every footprint of civilization also has a shadow.
The proximity to cattle, to their daily agricultural activities, and to the land itself, all this also generated concrete threat of being transmitted with different kinds of disease and infections. Like in recent cases of bird flu or infections transmitted by pigs, for example.
Still the great killer. That is malaria, that is our water and the presence of water and mosquitoes. But it has shifted other elements of agriculture, where agriculture may be related to modern ills and maladies, comes largely from prepared foods, not from the fresh food so much or the world, but to industrial foods. So prepared foods can often contain, of course, if they're not well prepared, bacteria, which can be deadly. The pressure on farmers and agriculturalists to produce massive, on a mass scale, food products, particularly in animals, has caused such diseases as mad cow disease.
Nevertheless, by 3500 BCE, farming had spread far across Eurasia. In only a few thousand years, sometimes for better and sometimes worse, humans have totally transformed this planet. In evolutionary terms, that's a blink of an eye. An example of this transformation is the Palm Islands in Dubai. These islands were artificially created, relying on the ancient method of irrigation. Around the world, there are many such examples that were created using ancient agricultural techniques. The ancients were the first to transform their environment from arid to arable soil. Now, in the not-too-distant future, man plans to leave the footprints of our current civilization on another planet. Contemporary scientists are working on ways to affect the climate of Mars, hoping to increase its atmospheric carbon dioxide pressure. This would have the effect of warming Mars and make it possible to successfully colonize. By increasing its atmospheric carbon dioxide pressure, a process called terraforming, we can also build up the red planet's atmosphere and water content, which would give us the ability to irrigate it. It's a very lofty ambition. NASA estimates that in order to make Mars habitable, it would take 400 years of terraforming and a mere $4 trillion. Thousands of years ago, ancient Egyptian farmers had a more modest goal. They sought to produce enough food to feed their population. In order to accomplish that, they would have to do some terraforming of their own.
I'm rather skeptical about that. Why? Because you basically don't have all the conditions that you would have here on the other planet. What is possible to say, however, is that what our ancestors did in Egypt or in Mesopotamia in terms of making those lands habitable and good for producing crops. So this was a real enterprise because those populations did not really have the instruments, the tools, the technical methodologies that we have today.
Without benefit of an instruction manual, the Egyptians terraformed along the Nile River. Practically everything they did was being done for the first time. They grew crops along the banks of that river. The crops benefited from the annual floods that left behind kemet, a rich black soil. This fertile soil was ideal for growing healthy crops. In its own way, Egyptian agriculture was as much of an achievement as the building of the pyramids.
It became important very early for the Egyptians to understand how to deal with their river in order to employ the water of the river itself to grow their crops and to grow grain along the river valley.
The Egyptians grew wheat, barley, vegetables, figs, melons, pomegranates, and vine. They also grew flax, which was then made into linen. Grain was certainly a versatile crop. The ancient Egyptians relied on it for their staple diet of bread, porridge, and beer. Egyptian farmers also grew vegetables, including cabbage, beans, cucumbers, lettuce, onions, and leeks. Through century after century, it's a way of life that hasn't really changed all that much. Famous for their canal system and their invention of the shadoof, they may have been the first to use the water wheel. They attached a bucket to a long pole at one end and put a weight at the other end. The buckets were dropped into the Nile, filled with water, and raised up with water wheels. An ingenious device. Traveling along the Nile today, you can still see the shadoof in use. A footprint of civilization? Well, let's just say, if it's not broken, why fix it?
It should be even more important. It should be acknowledged as more important, of course, a form of sustainable agriculture. And again, we have many lessons to learn from the ancient world, even in drier regions of the world that they control, using smart water infrastructures that were sustainable. Whereas today, as you know, with all the technology, the water has become more accessible, but that has also led to many problems in making the area more arid than before.
So this is a real footprint of civilization because how people still use the water of their rivers, how people still employ the water of their rivers today is very similar to how people of the ancient civilizations used to deal with the same aspect of their economical life.
The These days, we rely on sophisticated equipment and techniques to predict flooding, including data sensors, telemetry equipment, and satellite-assisted weather forecasting. But believe it or not, the ancient Egyptians invented the very first flood warning system. It was called the Nilometer. It measured the Nile and predicted its flooding. Between the peak of Egyptian culture and the start of the Roman Empire, Greece came to prominence as a culture and civilization. During that time, one item always seemed to be on the menu, regardless of the meal: cereal. The irony that footprints of civilization lead to the modern breakfast bar is unmistakable. In the Odyssey by Homer, the diet of the Greeks was depicted as pretty monotonous. The bulk of the grain cultivated was barley, which was turned into porridge or ground into flour to make bread.
We know that they had a 3-meal organization during the day, very early at dawn, to make the most of natural light and get ready to work in the field. So that's the equivalent of a breakfast. But their typical food for this first meal would include some cheese, some even fruit like figs, and some bread, and then they would be ready to go to work. Lunch did exist, but it was a minor meal. Sometimes available directly where they were was what they consumed. Later in the evening, there was the dinner. It's called depnon. That was definitely their most important meal. And this is when people who could afford would have a little bit more of a variety.
Perhaps their diet explains all those six-pack stomachs on ancient statues. Back then, farming was not an easy way to make a living. Some things never change, but in ancient Greece, the amount of good soil and cropland was limited.
The Greeks relied very heavily on grains and fish in their diet. Olive oil, for example, also. In fact, they developed the olives from what was a pit the size of one small finger into the magnificent variety of olives we still have today. So olives were a great consumption.
You could have some meat if the family was well off. Olive oil was very present, and it is known that olive oil and wine were very important component of their diet, not only because, of course, they make everything tastier and more pleasant, but because given the poverty and the limitation of their diet, these two extra ingredients supply vitamins for olive oil and some other substances that otherwise would be lacking from what was a very basic, repetitive diet.
When grapes were harvested, they might be consumed as raw fruit, or dried into raisins, or of course used in wine production. It sounds like the modern Mediterranean diet, a healthy diet emulated for centuries that is still fashionable. How civilized.
When the Greeks discovered the grape, which was wild at the time, also it was no more than a pit, the end of your finger, and they developed too the grapes more or less that we know today. Now we have many more varieties of grapes because of modern agriculture, but in large part, the wines we know today, the various kinds of grapes that make various kinds of wines, were known to antiquity also. Wine production was extraordinarily important, as it was also used as medical purposes and other cooking, for example. They cooked a lot with and wine, of course, and drank it all the time.
Ancient Greek farms, called stenochoria, were generally small, consisting of 4 or 5 acres of land. The farmers could grow enough food to support their families and perhaps a small surplus to sell in the local market. But there were some larger farms. These were generally run by farm managers, so the gentlemen farmers who owned those farms could live it up in the city. One record showed such a farmer making 30,000 drachmas a year from his estate. By contrast, the average worker could expect to make just 2 drachmas a day. The big food corporations and consortiums of today have an enormous share of the world's wealth. There are, in fact, just 10 companies that control practically all the well-known food and beverage brands in the world. Look, cereal again. These companies employ thousands of people and rake in combined revenues of over $350 billion per year. In ancient times, growing crops and tending livestock began as a matter of survival. But it didn't take long before men, being what they are, figured that food could do more than fill the bellies of their families. Food could be exchanged for goods and traded as a commodity in the market.
Until the Roman Empire does not appear to be any large food consortium. After the Punic Wars, 146 BC, however, there is a strong development in agriculture here, certainly in Italy, because the land-based agriculture workers had been taken off the farms, recruited into the military to conduct the wars which extended from 264 BC to 146 BC, the continual wars which constructed the Roman Empire.
They were called latifundia, so large estates, exactly the translation. And we see this problem becoming bigger and bigger. They started with a limited group of elite families, the patricians, already controlling the best and the majority of the fields.
The growth of the latifundia made it almost impossible for the smallholder to survive. If you have a small holding that is dependent upon a very small workforce, a husband, wife, and the children growing up and working, and the husband and the elder sons are away because they've been conscripted into the army, then it's left to a very small and perhaps enfeebled workforce that can't maintain a small holding.
Bread was the staple diet of Rome. Shortages of it could cause rioting or even rebellion. Thousands of years later, it's still something we see in the headlines of today.
This became very strong and very dangerous kind of riot, because the riotees threatened the Roman senators, so they had to escape. This is meaningful to make us understand also the power of the masses in Roman history. When the masses gather and put together their force and their power, they can really ask for more to their lords and to the ones who are politically responsible for their life.
There are countries in our modern world whose inflated economies are spiraling out of control. In some places, this results in shortages of basic commodities like food and water. The desperate populations there have taken to the streets more than once. The result? Looters plundering food trucks and state-run supermarkets, and even slaughtering livestock. This isn't to suggest that food riots are a footprint of civilization, but Rome's eventual response to these shortages was, for once, actually quite civilized. The Romans created one of the earliest government welfare programs. It was the 2nd century BCE, when some Roman senators established a wheat allowance for the poor.
Tiberius Gracchus is probably the first Roman who realizes the disparity between the displaced smallholder and the huge estate owner and wants to do something about it. Of course, his fellow senators are very upset about this. They don't like the idea that their newfound wealth is being undercut by one of their own. Eventually, the only way that Tiberius can be stopped in his land reforms, which were not that revolutionary at the end of the day, was by murdering him.
Consequently, these problems of food supply continued going on and on and on until Octavian seized Egypt from Cleopatra and Antony in 31 BC, and the Romans found themselves in all their glory occupying Egypt, the great food supply. The Romans began to bring enormous food supply from Egypt, grain, massive amounts of it. They developed ships that would carry massive amounts of this. They created a new port, Ostia Antiqa, to receive those grain fleets. They created enormous storage facilities down along the Tiber River, which are still in ruins. They can be seen today. And near Testaccio, all along, are huge facilities for storing grain. So they had a food bank, and they initiated a process of grain distribution to the population of Rome, of grain, oil, wine, and later in the empire they also distributed pork.
There even was a state officer and a connected position to monitor constantly and make sure that there never was a break in this continuous supply of grain. It was called a nona, and it was an important office that responded to the emperor.
Julius Caesar, a hard-headed man if ever there was, suggested people queuing for grain should be means-tested. That practice continued for hundreds of years. These were the first ever food banks, something still seen around the world today. Though the Romans could doubtless be a cruel lot, they also set the scene for some forms of social justice.
Let's take the example of the U.S. government. They have forever subsidized the agriculture in the United States and continue to do it. They must maintain a certain level of food supply. It's because that whole system, that distribution system, that production and distribution system is closely controlled by governments. And of course, that's exactly the relationship that the empire, the Roman emperors had in the ancient world. Their only legitimacy was the approval of the population. So they focused, unlike the Republic, they focused their attention, their favors on the population at large. And that's evident everywhere.
The satirical poet Juvenal famously wrote that the Roman Empire was fueled by panem et circenses, breads and circuses. Then as now, the rich and powerful, the high and mighty Senate, the noble consul or proconsul, the all-powerful emperor, still depended on the good graces of the mob or common people. And the people, said Juvenal with a sneer, could always be placated by two things, panem et circenses, bread and circuses. The trouble, of course, was that Juvenal was not suggesting this was a good thing. No, he was saying the common people were selfish, as well as being ignorant of and uninterested in civic duty. And the modern equivalent to bread and circuses could be junk food and violent video games, or maybe fad diets and social media addiction. Judge for yourself.
This is a typical footprint of a civilization that we still find today pretty much employed in contemporary political situation. So the Romans used to provide their people, the populace, with panem et circenses, meaning that people just received the little bit they needed in order to survive or not to starve in terms of food, and they also were provided with some fun.
The populace was ensured of a basic staple diet, grain to make bread or bread itself, and the amount of entertainment, either the gladiatorial shows or the circuses, that is the chariot racing, increased exponentially under the empire.
The success of the Roman Empire and its march across the then known world owed a lot to bread and farming. The Romans typically capitalized on the tools and inventions of all other civilizations that had come before them.
Well, it's because Rome production at all levels depended on slavery. And where you have slavery, a large supply of human labor, you're not prompted, you're not inspired to create machines to replace those slaves. In fact, it could be dangerous. If we look at the big picture, slavery continued in the Western world right up to the Industrial Revolution. It was only machines, when machines were available, that replaced the slaves. This was an issue in the American Civil War, in fact, big issue. That is, the southern states did not want to develop an industrial economy because the slaves would have to be freed. It would free the slaves. That was dangerous.
In order to irrigate their crops and plants, as well as to sustain both animal and human life, the Romans built aqueducts, dams, and reservoirs to store and carry water. There are Roman aqueducts still functioning today in France, Spain, England, and Italy. The Aqua Virgine in Rome, for instance, which supplies water to the Trevi fountains. The distribution of food and drink is one of the most important footsteps of civilization there is. But trade could only expand but so far over land. The sea provided bottomless food baskets, or so it seemed. They were teeming with life. All you had to do was get out there and catch it. In the modern world, the fishing industry is, to put it mildly, big business. In 2017, the worldwide weight of all the life hauled from the seas came to approximately 174 million metric tons. No wonder there are widespread concerns about the impact of fishing on the world's oceans. Demand is beginning to outpace supply. Contrast that perspective with how inexhaustible the ocean's bounty must have seemed at the outset of the global fishing trade.
In terms of the ancient civilizations, I would mention the Phoenicians. So the Phoenicians really represents the earliest example of a civilization which is pretty much projected towards the sea, because they were inhabiting a very tiny strip of land which corresponds to what is nowadays Lebanon, and they had a very long coastline.
Not only were they the great navigators of the ancient world, but they also invented sea farming.
This early civilization did not really have so many instruments and tools. They could not rely on sophisticated tools in order to navigate through the sea. But anyway, they were already expert in terms of the knowledge that they had of the sky and how to orientate their navigation according to precise points in the sky, so according to stars or according to the constellations, and also according to the motion of the sun or the moon.
The Romans will take the idea of sea farming to the nth degree, as they did with so much. Had agricultural fisheries. I mean, it was tended to be for the exotic end of the market and the production of eels and lampreys for the senatorial tables, but it was still sea farming and fishing on an industrial scale.
This famous fresco of a fisherman is from the excavation of the Minoan town of Akrotiri, located on the Greek island of Santorini. The volcano-ravaged ruins of this Minoan town tell us a lot about the first great seafaring nation of the Mediterranean, the Minoans. The Minoans were fantastic boat builders, great fishermen, and seagoing traders. We still admire the footprints they left behind of their civilization and their life at sea.
We know, for example, the Minoans had almost an obsession with fish and the sea, to the point of incorporating all kinds of fish in their art, including the octopus and other variety of sea animals. We know that fish was an important component of the Greek diet. However, in the Greek world, we still see fish as a very humble activity. It is with the Roman period that we witness a more industrial approach to fishing, comparable to our more modern idea.
The great fishing vessels of today. Trawlers catch large volumes of fish in their nets. Some of them are still fishing for tuna off the coast of Sicily. In ancient times, Sicily was an outpost of Greece. There's a poetry about life at sea, then and now. Modern man mustn't plunder the oceans with the abandon of our ancestors, but the ocean's food baskets will, most likely, help feed the world for centuries to come. If it were not for the early pioneers in agriculture, including irrigation, horticulture, and viniculture, we might still be roaming the wild, hunting for our dinner.
With agriculture and the developments in agriculture came civilization. Civilization through mathematics, counting the herds, and into literature, the development of alphabets, etc.
So pull up a chair and raise a glass to the footprints of civilization, which still lead us from the plate and the palate. What could be more civilized than that?
Man's appetite has not changed in all these 1,000 years. It may have grown a lot, it may have diversified, but food is the central item on the agenda all through history.